Now I'm going to demo how to use the stacked helix constraint in XRNA.js. So if we go ahead and select RNA stacked helix and we zoom into a portion of the scene, we can begin clicking and dragging in order to demonstrate the functionality of the stacked helix constraint. You can see that it takes a portion of the scene which consists of sort of a meta helix in a way. So it's a helix that is separated between single nucleotided regions, but they ultimately come back to form the same sort of meta helix. So this helix begins, it's separated by these two regions of single strands, and then there's another contiguous helix. And so it's like portions of the helix have been deleted or no longer base paired, but overall it sort of forms this continuous run of sparsely interrupted helices. So you can see that's kind of the notion of what a stacked helix is. If you want to use the middle mouse button to try to auto-detect the presence of stacked helices, I recommend that you not just grab whole portions like this, because most of the time you're going to end up auto-detecting an RNA subdomain, because a lot of stacked helix regions are also part of subdomains. So instead of that, you want to avoid capturing both parts of a base pair. You want to come along and just sort of capture a run, and that will auto-detect a stacked helix for you. So you grab, just to make it a little more clear, you grab this first base paired nucleotide, a couple of free nucleotides, and another one that is part of another helix. And just like that, you will auto-detect the presence of stacked helices. Of course, we have our positions, which we can edit, and also the color and font editors, as always. And just to show you that they work, this is how it works. And you can flip. And of course, the anchor of this stacked helix begins at the lowest index. So the nucleotide index 1418 here is base paired to 1613. So the middle of this base pair defines where our anchor for this repositioning edit menu keys off of. So now let's go ahead and format. You can see that there are 1, 2, 3, 4, 5, 6 individual helices involved. So if we go ahead and click, and just to be clear, anytime you're using this constraint, you want to right-click on a base paired nucleotide, not a free nucleotide or a single nucleotide, because it won't be able to determine that it is part of a helix otherwise, so you'll get an error. So now we have our base pairs editor, and we see that there are 1, 2, 3, 4, 5, 6 helices, just as we predicted. And we can use this, we can edit, or we can delete as we like. And so that changes the nature of these base pairs, and we can do whatever we like with that. We can create additional helices in the middle if we wanted to. So I'll just demonstrate how to do that really quickly. So let's say we want to create a helix of 2 nucleotides, so two base pairs involved, starting at 1442. So we select our RNA complex, 1442. And we have, say, this nucleotide is the one we want to key off of, so 1585. So DR 1585, and a helix of length 2. Let's go ahead and create that, and we want it to be auto, so it automatically determines exactly what kind of base pairs are relevant, and we create those base pairs. And just like that, we have another helix in our stacked helix. Finally, we can annotate, and just as always, there are going to be multiple regions for this stacked helix. So let's go ahead and create that. So you can see there are 10 total regions, and that corresponds to the number of helices multiplied by 2. So there's region 1, 2, 3, 4, 5, and then 6, 7, 8, 9, and 10. So you can go ahead and change that data if you like, but we're going to go with defaults, and we're going to go with every third helix receives an annotation. And just like that, we have our annotated stacked helix. So this has been the stacked helix constraint for XRNA.js.